maybe like 2 more minutes because I still see a bunch of people signing on and walking around.
Sounds good.
Okay.
No, I don't know.
I'm not muted. I will do it after. Oh, I guess there's 40 people. All right, Mark. I think you can go ahead and start, and we'll just mute ourselves. And if we have questions, we can save them for the end, I suppose.
Yeah. You know, I want to touch on the questions real quick. I want to be transparent here and let you all know that I may not have all the answers to your questions. I still want to get them down in writing, get them over to our technical services manager, Jim Moses, and we will be able to get you the answers. But I may not have the answers to all your questions, but still, let's get those in writing so I can get those over. With that being said, let's get started with the presentation.
Thank you.
All righty. So for those of you who do not know, my name is Mark Ellis. I am the Northern California Regional Manager for ALPOLIC Materials. We are a world-renowned metal composite material manufacturer based in Chesapeake, Virginia. I am going to stop my video here, and I'll just be speaking with you all. And any questions you have, please shout them out, ask them in the chat. Please ask them. If I don't know the answer, I'll definitely let you know, and we will be able to get the answer to your question. So what we're going to be going over today is the MCM building code for fire requirements. Now, we are a registered provider with AIA, so if you do want to receive credit or certificate for this presentation, please send me your AIA number if applicable. This is copyrighted material. Now, learning objectives. We're gonna explore the definitions of non-combustibility. We're going to look at the exterior wall assembly with emphasis on MCM and how the various designs and material use in that wall will affect fire safety. We'll review IBC requirements for MCM cladding, which is in section 1406. And we'll understand applicable fire testing per IBC for exterior wall assemblies with a particular focus on the NFPA 285, which is a required testing. Lastly, we'll discuss the role of engineering judgments and letter of equivalencies. So introduction, MCM is used widely around the world for the last 50 years because of its design versatility, functionality, formable, lightweight, rigid, long-lasting material. It's used on anything from single family to multi-story construction, as we all know. When you use MCM in accordance with the IBC, International Building Code, it is very versatile and very safe solution for your projects. IBC codes need to be followed. I'll touch on that plenty of times during this presentation. You must follow code. Although it is not a legal code, the IBC, it is the model code, and most local codes derive from the IBC code. So the local codes are going to be the legal codes. Remember, IBC is the model code. Now, our focus for this presentation, and something I will continue to refer back to, is we must follow our strict building code here in the United States. Understanding combustibility. Now, here in the US, we define what is non-combustible. We set the conditions under which flaming does not occur. Basically, you have to have less than 50% mass loss. You have to have less than 54 temperature increase, and no flaming beyond the first 30 seconds. And this will make sense later on in the presentation. So here in the US, like I said, we define non-combustibility. We define which flaming does not occur. The definition of non-combustible changes from country to country. This is something that's very important to remember. Our building codes here in the US are much different than those than our friends up in Canada, the European Union, Australia, Japan, and whatnot. So what is combustibility? Combustibility is about flaming, mass loss, and temperature rise. Like I just said, non-combustibility is defined as less than 50% mass loss, less than 54 degrees Fahrenheit temperature increase, and no flaming beyond first 30 seconds. The limits for combustibility are flaming, mass loss, and temperature rise, as I just said. If your material meets them, then it is non-combustible. There are a few tests. There's the ASTM E136 test, which is done in a vertical oven at 750 degrees centigrade. The same oven is used in Canada. A combustible material in the US can be classified as a non-combustible in Canada or vice versa. So that's something very important to note, that something can be classified as non-combustible in Canada, but combustible here in the US. US and Canada set limits on these criteria and use that to determine what is non-combustible material. Now, non-combustibility, as we read here in the US International Building Code, test ASTM E136 considers the material non-combustible if it has a less than 50% mass loss, a temperature increase of less than 54 degrees with no flaming beyond the first 30 seconds, and then up and at 750 degrees centigrade. And then our friends up in Canada have their own test and have their own limits down there below. Now, if the final product is a composite, which we're talking about, all materials must be tested separately and pass. In the case of MCM, it includes the skin, the core, and adhesives if used. Obviously, we don't use any adhesives at ALPOLIC, but some manufacturers out there do. Now, what is MCM? MCM is metal composite material. Now, in that MCM realm, you have your ACM, you have your TCM, your CCM, your ZCM, zinc composite, stainless steel composite. How is it produced? For those of you who are unaware, it's produced by the continuous bonding of two of the same or similar metal skins under heat, pressure, and tension to either side of a thermoplastic core. Now, this thermoplastic core allows for the uniform expansion and contraction of the both metal skins, ensuring thermal stability, ensuring the material to stay very flat and product performance. So there are some really important words here in this first paragraph. The first one is continuous bonding. This allows for the same consistent pressure, heat, and tension and paint when we are manufacturing the material. So continuous, very important, bonded under heat, pressure, and tension. This is going to ensure that the aluminum skins, whether it's aluminum, titanium, copper, zinc, stainless steel, it's going to ensure that these skins are bonded on tight to the core. You're not going to have any delamination, no oil canning and whatnot. And then thermoplastic core. This is the most important here. It keeps the material very, very flat, as we all know. Now, as I just talked about, in that MCM realm, you have your stainless, you have your titanium, copper, zinc. It offers rigidity, superior flatness, thermal stability of heavy gauge sheet metal. And we'll see too in our AIA #1 presentation, it's we have a little diagram. It's over 61% lighter than solid heavy gauge sheet metal. 4 mil material is excellent strength to weight ratio, pre-finished, flexible, lightweight, can be prefabricated or curved, used on all different sorts of material. Here's the structure of MCM. I'll just quickly go over this. Your painted MCM, you have your surface treatment, aluminum skins bonded to that core, surface treatment on top, primer, color coat, and clear coat if needed. And then natural metals, there is no finish on natural metals, so there's not going to be a finished warranty. It's just the natural metals bonded to that core. Now, the types of cores. Very important to note, there are two different types of cores available in the industry. There's PE core, polyethylene core, and there's FR core, fire resistant, fire retardant core. Now, as we read here down on the bottom, both cores are regulated by the IBC and can be rated Class A under the ASTM E84 and Canada's ULC S102 test. Now, PE is roughly 2/3 the weight of FR per IBC. PE can be used on an elevation below 40 feet. FR must be used on anything 40 feet or above. I know at Walters and Wolff, we love FR core, try to stay away from PE core, so that's perfectly fine. Now, FR material has been used as a component in wall assemblies that have successfully passed the NFPA285 and Canada's ULC S134 test. Basically, the FR core is achieved by adding a high percentage of mineral fill. The FR core suppresses the fire by releasing steam from its water-based mineral-filled core, basically the ATH, aluminum trihydroxide. And let's follow the code. Anything above 40 feet, FR core must be used, and PE core can be used on elevation below 40 feet. Cladding systems. We have various cladding systems available in the industry, like our rain screens, right? Our dry seal, wet seal systems. Not only do they bring a visual aesthetic, but they also act as the first layer of protection against air and water penetration into a building. I like to say rain screen systems let the building breathe, and sealed systems like wet seal, dry seal act as the building's main waterproofing. So we'll take a look at the systems here. We have our first sealed system, our wet seal system, which is going to be most economical. It's an open joint system sealed with caulk, backer rot, watertight. Now, wet seal, most economical, like I said. It's important to note that the caulk or sealant on the wet seal will need to be replaced every 5 to 10 years if exposed to heavy UV radiation. It will collect dust, it will collect dirt. You may see it stream down the panel when it rains. So that's something to definitely keep in mind when working with a wet seal system. Air water does not go through, so it's going to be your waterproofing of your building. Now for your dry seal is going to look very similar to your typical rain screen system. Usually it's going to have about a 1/2 inch gap from joint to joint. It's going to be an open joint system with gaskets, filler strip. It's going to be your watertight system. And typically most expensive, depending on what fabricator has it. We know Elward has their own dry seal system. It's really just dependent on the typical fabricator installer. Now, your dry seal system, like I said, it's going to be about a 1/2 inch gap from joint to joint, very similar to your rain screen. Costly system and labor intensive. Now, our 2 different flavors of rain screens. We have our pressure equalized, which is the ALMA 508 tested system, and then we have our drain back ventilated, ALMA 509 tested system. Now, the pressure equalized ALMA 508 that we're looking at right here goes through a very rigorous test. It's a pass-fail test. Now, there is going to be an allowable amount of moisture to get behind the panels onto the water vapor barrier. That's dependent on the test. And then the drain back ventilated goes through a similar test, but it's on a scale, rated on a scale through 1 to 10. So your ALMA 508 is going to be go through a much more rigorous test compared to your ALMA 509 drain back. But your drain back scale 1 to 10, like I said, rain screen systems, they do not rely on a single face seal approach. Oh, yep. Do we have a question? Nope, I guess not. All right. No worries.
I didn't hear anyone ask a question, but I did have I was gonna just briefly ask. I'm hoping that there's a good portion of this that focuses on the NFPA stuff.
Yeah. So why don't I need to, should I just go? Okay.
If you don't mind.
Yeah.
And then we can, if we have time, we can backtrack to this.
Okay. Yeah. No worries.
I appreciate that. I'm so sorry. Yeah. Thank you.
No worries. Okay. So we're on cladding systems. Components of the wall system include cladding, barrier, studs, insulation, substrate, etc. The only insulation that we're aware of that passes the NFPA 285 with MCM are mineral wool, polyiso, and phenolic. Often, insulation is the most combustible part of the wall. Now, simply, there is a trade-off between an insulation's energy efficiency and fire performance. In the case of insulation, a greener building material may be more combustible. As we read here, all insulation used in MCM cladding should be tested per NFPA 285 for fire performance. No construction is without risk, but the building codes lay out allowable procedures to mitigate that risk. For testing, building code. IBC section 1406 covers MCM. Really, the 40 foot exception was incorporated into section 1406.10. Now, when we get into testing, you have the ASTM E136 test, which is the standard test method for assessing combustibility of materials using a vertical tube furnace at 750 degrees centigrade. It's important to note that no MCM passes this E136 test because MCM is combustible. Now, basically, think of the ASTM E136 test as a core test, and then you have your ASTM E84 test, which is think of it as a sheet test. Now, it's basically the standard test method for surface burning characteristics of building materials. Both the PE and FR core meet ASTM E84, but no MCM in the US passes the E136, like I just said. Now, ASTM E136 test is for the core, and NFPA 285 is for the composite wall assembly. For MCM to be non-combustible, both the ASTM E136 and NFPA 285 need to be passed. The code requirements requires an MCM rated ASTM E84 Class A material. Now here, AFCMD 1929, standard test method for determining ignition temperatures of plastics. This is in section 1406.11. All right, now talking about NFPA 285. Now NFPA 285, it's found in section 1406.10. It is the standard fire test method for evaluation of fire propagation characteristics of exterior non-load-bearing wall assemblies containing combustible components. It's been around for more than 40 years, which increases the consistency and safety of the test. Real-world sample for fire tests with realistic level of difficulty. The test simulates an event where the flame will shatter the window and spread from the room to the open air for more oxygen along the external wall. Material that is rated Class A in the ACM E84 will not inherently pass the NFPA 285 as part of the assembly. So that's something to keep in mind. Now, here are the changes to the NFPA 285 test. I'll just quickly go over these. In 1998, the first edition, 2019, most recent. In 2021 edition, the core did not change, but the wall system did. So in the next year or two, it is expected to have another revision, which will be more strict. Now, here is the setup of the test. Like I said, 1406.10.4 full scale test. The MCM system shall be tested in accordance with and comply with the acceptance criteria of NFPA 285. Such testing shall be performed on the MCM system, which the MCM is, in the maximum thickness intended for use. Now, it's a 30-minute test on a 14 by 18 foot mock-up. There are two sets of burners. There's one gas burner that's inside of the room that burns for about 5 minutes, the first 5 minutes, and then there's a flame that's on the outside of the building, as we can see here, and it burns for the next 25 minutes. And basically what it recreates is the flame burning from the inside of the building, outside, wanting to climb that exterior cladding. Now, if the flame does not reach the second floor during the test time, the material passes. There are thermocouple sensors throughout the test that can't get above 1000 degrees Fahrenheit. If they do, the test fails. Now here we have, you can see the thermocouple sensors here. These are the these black dots. Now these are going to be the temperature readers. Now it's usually thermocouple number 11, which is going to determine if the test passes or fails, because this is the one that usually, the one that usually fails is thermocouple number 11. So that's the one that determines if really the test is going to fail or pass. Here's the front view of the NFPA 285 test. The test requires a center vertical joint. There's no tolerance to one side or the other, and a horizontal joint about 3 feet above the window. Now here, test procedure, recording the equipment started, ambient conditions documented, in-room burner ignited for the first 5 minutes, the window burner ignited after, and burn energy increases at 5-minute intervals. Like I said, it's a 30-minute test. And after the 30 minutes, 10 minutes of observation period, and you're going to also observe back of the wall panel and front of the wall sheathing. Now, passing temperature at 10 feet above opening should not exceed 1000 degrees Fahrenheit. As you can see, the flame, it's burning off that aluminum skin, and now that FR core, the water-based inorganic minerals, once it gets to about 375 degrees, it starts to release steam. So that's that's some cool technology that's in the FR core. You have your vertical flame propagation of components, installation shall not occur. Horizontal flame propagation of components, installation shall not occur. Temperature rise in second story shall not exceed 500 degrees. No flame in second story, no flame beyond intersection of test sample and test apparatus. Now here, simply, this is just to illustrate NFPA 285 setup and thermocouple placements. Here are some examples of after the NFPA test has been completed. You see the aluminum skins being burned, and it's just it's just showing that FR core. The FR core really releases steam. You're not seeing delamination here. You're seeing steam being released.
So Mark, is that the big difference between the FR core and the PE core? The
Correct.
FR core kind of allows the steam to go out, so it doesn't just encapsulate the heat and the fire?
Exactly, Steve. That's the big difference there.
Okay. Thanks.
Yep. Some more examples. All right, now here's, like I just talked about NFPA 285, let's talk about it again. Like I said, it's a 30-minute test. It's on an 14 by 18 foot mock-up. It's not just an assembly test, it's a whole wall test, as we can see here on the right. Whole wall test. So you're testing everything from the inside, inside wall to the outside wall, inside wall to the outside cladding. Now, there's a flame that's on the inside of the inside the room that burns for about 5 minutes, and then there's a flame on the outside of the building that burns for the next 25 minutes. Looking for flame spread and smoke generation. Before ignition, 7 minutes in, notice the length of the flame here. Now, 15 minutes in, you're not seeing delamination. You're seeing that water-based inorganic minerals releasing steam. Now, 10 minutes later, 25 minutes in, notice the length of the flame. It has not spread, and this test passed. So that's an example of the NFPA 285 test. Our friends up north have their own test. ULC, S134 test, obviously not in the code here in the United States. Now, letters of equivalency and engineering judgments. Now, engineering judgments, they evaluate material substitutions to ensure that there is no added fire risk to the assembly that was tested to the NFPA 285. Now, bear in mind, building officials or the authority having jurisdiction may have more stringent requirements than what is laid out in the code. Some parameters to be reviewed are as follows: cavity depth, types of insulation, types of weather-resistant barriers, sheathing, mounting, extrusions, support system, even paint being used. Construction types. Now, simply, the IBC breaks all commercial construction into 5 types, with 1 through 4 being non-combustible and 5 being wood. Passing the NFPA 285 allows use in all types. The one big takeaway, though, only fire-resistant cores passing the NFPA 285 can be used in projects over 40 feet and types 1 through 4 construction. MCMs that have not passed the 285 can be used in all construction types, but with the height restriction of below 40 feet. Wall types. Now, this just shows the thermocouple placements in a typical wall, which uses separate substrate, air, water, vapor barrier, and continuous insulation. And slide 40, we have basically just shows a wall with a combined substrate, air, water, and typically a polyiso such as RMAX. Now, looking at specifications, really, you got to make sure you must use FR core above 40 feet. PE core per IBC is acceptable to use below 40 feet. In grade, ESRs are available. So I have a performance-based spec guide that I can send you all if needed. And conclusion, that does it. Follow the code. That's really what I want to touch on. Follow the code. Is important to distinguish the resiliency of the US and Canadian code because of the robust standards and the attentive examination of both the building construction and fire requirements. Wall cladding featuring MCM for over 40 feet from grade must use a fire-resistant core and be fabricated in assembly that can pass the NFPA 285. And ladies and gentlemen, that does it. Do we have any questions?
I just want to reiterate the composite panel, even the fire rated, does not meet the NFPA in a curtain wall system because it has not been tested as an assembly.
Exactly.
But
yeah,
if you had a stud wall or sheathing, then in that case it would be able to pass, correct? But if you don't have
right, and it's so it's basically what the test has been set up to. There hasn't been a test for curtain wall, so if Walters and Wolf wants to be the guinea pig for that test, we can certainly get you with management and we can set that up. It's going to be expensive, but it's not out there. It's not available, and so it would definitely help. I know Walters and Wolf and others if there was a test, because I know on your well, when we spoke to Jim, we were talking about using an NFPA test in a curtain wall application, and there is none. So that isn't available, but we can certainly try.
For the test on the panel system that's on the sheathing,
Yeah, right.
What
Yep.
were the clips made out of? Were those aluminum extrusions or were those?
Yeah.
Steel?
So it's typically aluminum extrusions, but it's going to be all dependent on what types of system that certain fabricator uses. So it's going to vary.
And there's not a concern with those clips melting and the panel staying in place?
No, there's not. You know, it basically, you know, you really just have to look at it through the test. And you know, most of the time, using attachment systems like that, the test passes. So there is no concern.
Okay.
So wouldn't it also, just curious, would it maybe also benefit you guys to perform this test? Because if you guys had this test, I think more people would be able to utilize the product, right?
Yeah, we do. Our material is going to pass this test. It's really, like I said, it's not just an assembly test, but it's a whole wall test. So it's everything from, you know, whatever system you're using, our material is going to pass the test. It's all about,
Regardless, yeah.
yeah, it's all about what type of system is going to be used. And if that system with our MCM, is that going to pass?
So it has to be that particular system.
Yeah, so it has to be the particular system.
Has to be a curtain wall
Yeah.
specific.
Yeah, but like our W75 versus something else.
Hmm.
So like Connor could take the system and use it,
Mhm.
test it, it's not the same system. Because the civil system is tested, not just for.
Yeah. Does anyone else have any questions for Mark or comments?
Yeah, I had a question. Do you guys have examples of rated assemblies with these panels? We have a job coming up where we're required to have a 1 hour rated, and exterior cladding is a FR core,
Right.
1mm.
It's not gonna pass.
Yeah, you know, Gabriel, that's a good question. I am not too sure. Why don't we get that in writing and I can get that over to Jim. I'm not too sure on that answer.
Okay, I will email you.
Yeah,
Hey,
thank you.
Mark, from a scheduling standpoint, if you were to do a test, what is how long is this test, and how long does it take to get this whole thing put together? What's the typical duration for that?
So I know the cost is between 40 to 50 grand, and it takes about 2 to 4 months to schedule.
Right, so we did a UL test, the whole process of that fire example is what we did. So yeah, I mean, it can be done fairly quickly, Paul. I feel maybe even sooner. It's just getting in line with
Right.
the lab that
Right.
has the ability. Are you showing us jobs?
Oh yeah, so here we have a few Walters and Wolf jobs. We have Kaiser Permanente Mission Bay.
Lisa?
Yeah, it looks beautiful. Moffett Place, Google Campus. This one's one of my favorites.
I didn't do.
And then
That
this
was
one.
on the 6th.
This one screams California. You have the California poppies. You have Google. What else really do you need? You have the Google Event Center. 1255 Pear, and lastly, one of my favorites, Natural Resources Building in Sacramento.
Bikinis.
I could have guessed that one.
That's beautiful. Even though I do not like this Alucobond down here.
That wasn't
But, you
us. That wasn't us.
I know it wasn't you. I know. So do we have any other questions before we log off here?
A few months ago, Mark, I emailed you a question on a 751 Gateway. The architect was asking if there was a Class B flame spread rating, and then you replied like, "Hey, like we meet Class A," but I didn't see any mention during the presentation about different class ratings.
Yeah,
Is,
you know,
is A just like the best and you're good, or are there other variables that might pop up in discussion?
That's a good question, and I'm not going to have that answer. So why don't we get that? Why don't we get that over to Jim? If we can get that down in writing, and I'll be able to get that answer for you tomorrow or later on today.
Okay.
So if anyone has any questions, even after the meeting, Mark's email address is in the meeting invite that Tom sent out. So feel free to shoot him an email or give him a call.
Yep, absolutely.
Mark, one quick question. This presentation,
Yes.
is that something maybe you could send to Candace, the slides, and
Absolutely. Yep.
we could copy that, Candace, to everyone?
Yes, or
No problem.
I think it was recorded too.
Well, yeah, Tom recorded it.
I'm recording it. Just to have the copy of the slides, the
Yeah.
presentation.
No problem, Tom.
So, sorry, one last question. So the P core is considered combustible material, but the F core is also considered combustible?
Correct. Yes,
Okay.
correct.
Well, appreciate your time, Mark. Thank you so much.
All
We'll
right,
definitely
Candace.
be in touch on the UCSF job, and yeah, have a great
Awesome.
holiday.
Thank you. Yeah, likewise. Thanks everyone for joining, and reach out
Mark.
if you have any questions.
Thank
Thanks,
you.
Mark.
Thank you.
Thank you.
Thanks,
Bye.
Mark.